So in this video I'm going to talk about a new type of algorithm which is different than the k-nearest neighbor algorithm, which is a supervised algorithm. But this one, the k-means clustering, is an unsupervised algorithm. Before you know the k-means clustering does and how you solve those problems with k-means algorithm, let's just understand the unsupervised and supervised. The unsupervised is simple, which is that you won't be given a labeled data. A labeled data is what type of thing? See the example. So here in the k-nearest neighbor algorithm, this is actually the k-nearest neighbor algorithm that I make a video on. So please check this video out so that you can understand it more perfectly. The k-nearest neighbor, we have the data sets given, which is our training data set. Okay, this is our training data set. So with that we have a class given. If the point is 4.2 and 2.8, it class belongs to 1. The result is always 1 or 0. Either it is belong to class 1 or it is class belongs to 0. So there is a label given, yes or no. But in case of k-nearest neighbor, you won't be given class 1 or 0 or class dog or 0 or class dog or cat. You won't be given that. This is a label data. K-means clustering is unsupervised because there is no label data like the KNN algorithm, which is a supervised algorithm. So this is the main difference between supervised and unsupervised algorithm. So I took KNN and k-means side by side because those two algorithms are pretty similar in such a case that we use the same formula, okay, the distance formula. So the most important thing is that the cluster and centroid based algorithm, k-means is always cluster based algorithm. So cluster means a suppose group. In a group we have 50 students. In two groups we have 50, which is 100 students. It can have many groups and each of them has several number of items as well. So another thing is that there can be multiple cluster. We call it like suppose mu1, mu2, mu3. You can also write it like that, c1, c2, c3, like that. So this means that this is the centroid of those cluster or of those group, or you can understand that this is the captain of this cluster 1 or the center point of the cluster 1. This is the mu2 is the center point of cluster 2. mu3 is the center point of cluster 3. Now you need to find, this is your unknown data, this is your test data, this is the thing that you need to find or identify if this test data belongs to which cluster. Is it belong to mu1 cluster, or it belong to mu2 cluster, or it is belong to mu3 cluster centroid. So this is the thing that you need to identify in this algorithm. So this is the main thing. And so the unknown data point is closest to the cluster centroid mu1 is belongs to mu1. So this is the main part of this algorithm. You need to find the distance from this unknown data to this cluster mu1, and also you need to find the distance from this point to mu2 and mu3, because you need to find the smallest distance from this point to mu1, from this point to mu2, from this point to mu3, which is the centroid. Whichever is closest, suppose mu1 is closest here, so it will belong to mu1 cluster. Okay, it can be like mu2. If it is close to mu2, then it is belong to mu2. If it is close to mu3, then your unknown data point is belongs to mu3. So this is that we need to classify properly, because there is no label data here like class 1, class 0, or dog, cat, those type of things. We do not have label data. Suppose we have a center point at 1 and 1.5. so this one. So this is our center point. So write a circle. Another is 3 and 1. So this is also our center point, and it also have a cluster. So there are two clusters. Okay, so this is mu1, this is mu2. Okay, so within that you need to find a data point. Suppose your data point is this one, 2.8 and 0.5, this one. So is this data belong to mu1 or mu2? How you identify it? It is obviously close to the mu1, so that's why it is belongs to mu1, because this data point 2.8 and 0.5, this data point here is close to mu1, so this is belongs to mu1, not this one. Suppose another point, suppose 1.3 and 1.7, 1.3 and 1.7, this data point. Is it belong to mu2 or mu1? Obviously it is belong to mu2 because the distance is closer to mu2. Obviously it is belongs to mu2. So this is the main theme of this algorithm. So our main ultimate formula is 1 divided by m. M is the number of the items in your datasets. Summation of 1 I is equals to 1. It can go up to m, which is the number of items given in your datasets. And you need to find the xi value or individual data point minus mu k. Mu k is the number of cluster that you are in. So you need to find the distance from your given data point x, and you need to find the distance from the mu k and their difference and whole square. So this is the main formula. Okay, so here x 1 2 3 4 up to the m is the number of training data that you are given in your dataset. Mu1, mu2, mu3, mu k is the number of center in a cluster. Here we have only 2 clusters. There can be 3, 4, 5. So we say there can be mu k number of cluster possible. So your dataset is given like that, this way. X is 2, 2, 5, 6, 5 and 2.5. Y is 4, 3, 2, 2, 2.5, 3.5. So within this we need to just define the centroid position. Okay, so what is our centroid here? Here 2.2 and 4. Suppose this is 2 and this is 4. So this one is our centroid. Okay, 2, 4 is centroid. This point is our centroid. Now let's take another. It can be random. You can take 6, 2 and 2, 4 as centroid, and you can also take 5 and 2 and 2, 4 as centroid. So we have taken the 2 and 4 as centroid, which is mu1, and 5 and 2, this should be our 5 and this should be our 2. So this is our another centroid, which is mu2. So this is our another centroid, this one mu2, and 2 and 4, this is our another centroid, which is mu1. Now we need to classify our unknown data point and find the distance from mu1 and mu2 and see which it belongs. So here we can see find the distance from unknown data point from the centroid mu1 and mu2. Mu1 is 2, 4, mu2 is 5, 2. We have taken this from here, 5 and 2 and 2 and 4. And then our first training data point is 2, 4. Okay, so for that we need to find the distance. So we need to find distance from 2, 4 to mu1. So mu1 is also 2, 4. So the distance obviously would be 0 because they are the same. Now let's find our training data set is 2, 4. We need to find the distance from this mu2 to this data point. So our mu2 would be 5, this 5 minus this 2, because this 2 is the data point. We have to find the distance from this 2 position, whole square, plus 2. 2 is actually this 2 minus 4, this 4, whole square, and obviously you need to add root over of all of them, and the result is 3.60, So which one is the smaller? So from this position, which is very closer, which centroid is closer? Obviously this centroid is closer because the distance is 0. So our mu1 cluster is assigned to the closest as this data point. So we need to update mu1, but as you can see, mu1 has only one data, which is 2 and 4. We do not have any other data till now. If there is 2 or more data, then we need to update it. We will see it later. Now let's work on our second training data point, which is 2, 3. Now this is actually the 2, 3. So mu1 is actually 2 and 4, mu2 is 5 and 2. So 2 and 4. So our mu1 is actually 2 minus this data point 2 whole square plus 4 minus this data point whole square is equals to 1. Mu2 is equals to root over 5 minus this position, which is 2 whole square, plus mu2's y is actually 2. So this 2 minus this value 3 whole square is equal to 3.16. So which is closer? mu1. So 2 and 3 data point. So this 2 and 3 data point is actually assigned to So this 2 and 3 data point is assigned to cluster centroid 2 and 4, which is our mu1. Okay, so this 2 and 3 data point is assigned to mu1 cluster. So now we have two data in mu1. First we find 2 4 is belongs to mu1, which is this 2 4, which is this 2 4, which is first training data. And also the second training data 2 3 is also belongs to mu1, okay, because it is close to this. So there are two values, 2 3 and 2 4. Now we need to find the average. 2 and this 2, add those two divided by number of items, which is 2. 4 plus 3, okay, or you can say 3 plus 4, this 2 y element, divided by 2. Just add and divide by number of items. So we need to add, this is actually 2 and 3.5. So our new mu1 is actually 2 and 3.5. It is updated. We cannot use mu1 is equals to 2 and 4 again. We need to update it because there are two training data set, 2 and 3 and 2 and 4, which is belongs to mu1. Now we need to sum them up and average those values, and we need to update it, which is mu1. Now let's find for third data point, which is 5 and 2, and same we need to find the distance. Now 5 and 2 is actually this 5 and 2. So 5 and 2 data point, which is our third data point, which is close to mu2. Now 5 and 2 would be assigned to mu2 as it is the closest point. Now mu2 has only one value, which is 5 and 2. So we do not need to update it. Now same for fourth data point, which is 6 and 2. You need to find the distance, which is 2 minus 6, this value, plus 3.5, which is the new value of mu1. Let me see it again. So as you can see, this is our 2 and 3.5, this is our new mu1. So we need to calculate this one. So about 2 minus this value 6 whole square plus 3.5 minus this 2 whole square, which is 4.27. Mu2 is actually 5 minus this value 6 whole square plus 2 minus this value 2 whole square, which is 1, which is so 6.2 is closer to mu2. So 6 and 2 data point would be assigned to mu2 cluster. So mu2 now has two values. Previously we had 5 and 2, now we have 6 and 2. Now let's add 5 plus 6 divided by 2 and 2 plus 2 divided by 2, which is actually mu2 is 5.5 and 2. Now what should we do? Okay, now there is two values, so we just updated the mu2. Now mu2 is 5.5 and 2. Now don't do mistake, because some people will make mistake here. Some people think that still now mu2 is actually 5.2, but actually not, because it is updated. Okay, it is updated. Now it is 5.5 and 2. Now for fifth data point, our fifth data point is 5 and 2.5. We need to find the distance again. Our mu1 is 2 minus this 5 whole square plus 3.5 minus this value whole square, and mu2 is 5.5. Now this is updated value, 5.5 minus this 5 whole square plus this value, which is 2, minus 2.2 is actually this value whole square, which is 0.70. So this data point is belong to mu2. Now mu2 has total 3 value. Previously we have 5.2, 6. Previously we have 5 and 2 and 6 2. Now we have 5 and 2.5, which is also belong to mu2. So total there are 3 points. So you need to sum them up. 5 6 5 divided by 3 number of items, and 2 2 and 2.5 divided by number of items 3. So our new mu2 is actually 5.3 2.17. Okay, so based on that we calculate the sixth data point, which is our 2.5 and 3.5, and just find the distance. Okay, find the distance and we get 0.5 and 2. Now this point is close to mu1. So mu1. Now mu1 had previously 2.2 and 4. Now new point is 2.5 and 3.5. Previously we had mu1 as 2 4 2 3. Now we are adding 2.5 and 3.5 also belong to mu1. So you need to add all of those and sum them up again like previously. And our ultimate mu1 is this one, and our ultimate mu2 is this point. So let's point all of those. So let's add those mu1 and mu2 as our centroid. Mu1 is 2.17 and 3.5 and 3.5. So this is our centroid. And another is 5.33 and 2, which is this, so this point. Okay, so this is our centroid. And let's add all those data point, which is 2, 3, 2, 4. This would be coming from our training data, which is training data is actually this training data. Let's plot this. Let's plot this, which is this 2 and 4, 2 and 4, and also this is actually 2 and 3, 2 and 3. This is our training data. This is our training data. And because mu2 has 3 values total, this one, and this one, and also mu1 has 3 surrounding values, which was this one, and this one. Total 6 values. And their centroid is this, which is 2.17 and 3.5, which is this value, and 5.33 and 2.17, which is this value. This is their centroid. Now see the magic. 2.17 is coming from adding 2 plus 2 and 2.5. Okay, so 2 plus 2 plus 2.5. If we add all those values divided by number of items, which is 3, then we get 2.17. This is for x. Now let's find for y. For y, we are adding, for these 3 points, we have 4, 3 and 3.5. 4, 3, 3.5 divided by 3, which is the number of items here. So we get 3.5. Now 3.5, 4, these points y, 2 which is 4, and this 3.5 and this 3. Add those 3 values, divide by 3, which is 3.5. So if there are, suppose 5 of these dots, which is data points, if there is 5 data points, then we need to add all of those 5's x to find this value, and all of those values y, and sum and divided by number of those 5 items to find this y value. Okay, so this is, remember that because there is only 3 values, so we are just adding 2, 2.5 and 3 to find this value, and for y we have 3, 4 and 3.5 to find this value. Okay, so keep in remember that if there is multiple items like 5 or 6 items, we need to add all of those items to find the centroid, and add those items to find the centroid, because this is actually the, now we classify and clustered our all of those elements based on our cluster, and based on which is close to which value. Now we can identify it. Now if one says that what it belongs to, 5 and 2.5, which it belongs to, obviously this point 5 and 2.5 would be belongs to mu2 class. Okay, so this is how we can identify it, we can cluster it. We are clustering all of those small data set because they are closer to mu1. We find the distance from mu1 and mu2, and if it is closer to mu1, we assign it to mu1 centroid, and if it is close to mu2, we are assigning it to mu2. There one more important thing, which is our elbow method for optimal k. What is the optimal number of cluster that we should get? You cannot have 10 or 12 cluster, then it would be a really mess, and the performance of your algorithm would not be great. And as a data scientist also, you need to identify which is the best optimal solution. So to find that, you need to know the elbow method, especially for the K-means clustering. This is the sum of square distance. So this is the sum of square distance. Suppose in the beginning we have a huge distance, which is 3.5 suppose. But when you are decreasing the distance, suppose decreasing the distance, when your k value is actually 1, there is a huge number of distance because here k is 1. But when you are increasing the k, which is 2, it means that we have 2 cluster, okay, mu1 and mu2. Then our distance is smaller. And when our k is actually 3, then our sum of the square distance is smaller. So our distance is smaller. This is what we want. This is the most optimal one. When the k is 3, when there is 3 cluster here, 3 cluster like that, that is the most optimal. So this is actually the elbow point. When there would be 3 cluster, this is actually the elbow point, and this is the optimal solution. So as you can see, for k is equals to 3, optimal number of cluster is k is equals to 3. So this is why this the shape is like elbow. So this is the called the elbow point. So this is the optimal solution to find the proper number of cluster in this K-means clustering algorithm. So this is the thing that you need to learn very well in this algorithm. So thanks for watching, guys. This is all the things that I know about K-means clustering. If I know more about this and what is the best use case of it, I will obviously update it. Thanks for watching, guys, and I will catch up in the next video with decision tree and naive Bayes algorithm. So keep in touch with me. Thanks, guys. Thanks for watching.